So welcome, all of you, and also welcome to the people in the stream joining us for this highlight right before the lunch break. And it's my great pleasure and honor to introduce two esteemed colleagues of mine, the senior consultant, Dr. Michael Oberparleiter, and the principal consultant, Dr. Marie Bieth. So Michael joined us with a background in theoretical plasma physics and then worked at TNG as a full-stack software engineer before launching himself into various AI ventures during the last year. Marie, on the other hand, already used AI during her PhD, where she used machine learning applied on medical imaging, and then worked at TNG in various different roles, such as AI engineer, software engineer, chief technical director, and product owner, just to name a few. And today, they will teach us about how to use AI for automatic test generation, something which I hope to apply in my daily life as a software engineer, which will make my life easier. Please keep your questions until the end of the talk. And with this, Marie, Michael, the floor is yours. Go ahead.
Thank you. So welcome everyone to our talk about how to generate unit and end-to-end tests with AI. And the first question is, why would you even want to do that? Well, I don't know if it's happened to you. It's definitely happened to me. You change team or maybe arrive in a new project, maybe a new company, and you join an existing code base. So there's a big legacy code base. You start your work, you do your first pull request, and then you think, well, how do I know if I broke anything? Well, no test. Well, then I don't know. And sadly, we have not built a time machine to go and speak to the original developers and just explain, if you will just write the test now, my life would be so much easier afterwards when I join. So we don't have that, but we have built two tools that can help you catch up on these missing tests afterwards. We'll concentrate here on two types of tests in two parts of this presentation. The first one is unit test, and the second part will be about end-to-end tests. So let's start with unit tests. So why unit test? Well, I'm sure you've seen this test pyramid before, and the unit tests are right at the base of the test pyramid, right? So there's many of them, they're quick, but because there's so many of them, they actually take quite a bit of time to write. And so if you don't write them whilst you develop your project, your feature, there's very, very little chance that you'll have time to catch up on them manually later on. Additionally, they are less complex than the other ones because they test typically just one component, so they're actually easier to generate. And finally, they have a nice bonus for the unit test, which is there is well-established metrics on how you can evaluate whether you have enough of them and whether they're actually good, they're actually testing something. That means if you generate or if you work on a tool to generate these tests, you can also then evaluate how well your tool is actually working. So we want to generate these unit tests with AI. And the simple approach would just be I take an LLM, I give it some code, and I ask for tests. And depending on the complexity of your code and the actual LLM you use, this might work. On the other hand, you might also instead get this. It looks like a test, right? It has some mocking, it's actually calling some production code, and then it has some asserts. So all good, right? It's testing something. Well, no, it's not, actually. You'll have to believe me somewhat on that, but if you look more in detail at what it does, it's defining a mock, then this mock actually comes directly out of the production code again, and that's the part where you have to believe me, and then it's comparing it in the assets to what comes out of the production code. So it's really just testing the mock. Whatever your code actually does, this test is always going to be green. So that's not what you want. And if you think about it, if as a person you're writing tests for code you don't know, you actually have to go to this code, try and understand it, what does it do, then actually think about what you want to test, so define some test scenarios, then write the test, and then typically they might not actually work on the first try, so you might have to iterate a little bit to make it compile and make it run. And so this is actually more complex than just one step. And that's why we found out that also having several steps in the tool to generate this unit test also works best. So I just want to go with you through this. So our tool works, you have a production code, and then this production code goes through a workflow that has several components that work together to, in the end, produce good tests. You can call it an agentic approach. The main difference that we have here is that this workflow that I'm going to describe in a minute is actually fixed. So there's no liberty here, no decisions to take. After step 1 always comes steps 2. There's never step 4 after step 1. And this gives the whole thing some more stability, and it's different to other agentic tools that you might know. So how does it work? We have this production code. Typically, for unit tests, you take one class for which you want to generate some test, and we give it to a test writer that will write the first version of the test code. So that's what you have here. And then the test code goes through a feedback loop, because typically it won't be working on the first try. And so it's going to go through a loop with a test runner and a compiler, I mean, the other way around, the compiler and the test runner, and an error fixer that will fix any error that is flagged by this compiler and test runner. And this improves the test code, and so at some point it finishes, hopefully everything works, and we have working test code. So I'll go in detail through each of these components and then talk about a few more important aspects afterwards. So first, the unit test writer. Here again, you can take the simple approach, just asking for tests for some class that you have, and this might work. But our experiences, in particular, if your code is very complex, or if maybe you don't have access to the smartest LLMs in the market, maybe something smaller, then you might want to do that in multiple steps, and you get a much better business logic coverage from your test. And the steps would be you take the code that you want to test for, you ask this unit test writer to describe, or the LM rather, to describe what the public methods of the class do. So these are the ones you actually want to test. Then you ask it to define some test scenarios. So no code yet, right? Just text. And then when you have these test scenarios, then you ask it to actually generate the corresponding tests. So if you do that, you can even generate these tests then in parallel from your test scenario, but then you have separate tests. That means you need to merge them in the end to have it all in a test class. Sounds easy. It's a bit more complex than that, because for each of these tests, you will have mocks, typically at least, and you might have a setup and a teardown, and you need to merge all of these to work in just one test suite. But after all of that, then you have a first version of your test suite. And then we want to go into this feedback loop, and for that we need first the compiler and the test runner. These are really completely classical components here, so there's no magic, no LLMs, nothing, just like the tooling that you have in your repository, some engineering, and the log files or the logs that come out of these tools. And depending on the tooling that you're using in the project, we recognize it to actually use it. And last but not least is the error solver. And that's actually really important. It's responsible for fixing all the errors that can come from the compilation of the tests that were generated, or actually running the tests and finding that they're read. So what does it take? It takes the test class that you have, that you want to fix, and then the error logs, so either from the compilation or from the test runner. And then it's, again, a two-step process where it's asked to explain the error, so what could be the cause, where's the error actually happening in the code, and how would it solve it, and then actually write a patch to solve it. Why do we generate a patch here? Because we found that if we just ask the LLM to solve it by then generating the full file again, some unintended stuff happens where maybe another test just disappears. So we don't want that. Instead, we generate a patch. It works much more stably. The side effect is that we need this LLM to actually then stick to the patch format, because if you get an invalid format for your patch, of course, then you can't actually apply it. With modern LLMs, sticking to the patch format actually works really quite well, so this is a good approach for us. So going back to... Sorry. So going back to the actual workflow, this is the workflow for one class. And if you have some objective that you want to achieve and you find at the end, well, you haven't achieved it yet, then you can, of course, go back from the start, bring in the test that you already have, and ask the system to generate more tests for your production code. And if you want to do it for several classes, which you typically do, then you just can go through this loop for every one of your class, and do that in parallel as well if you want, and if you have enough rate limits in your LLM. So that's the approach, and I want to stress again that this feedback loop at the end really makes all the difference, because if you just have the first step with writing the test code, even with best-in-class LLMs, so the top-of-the-line commercial ones, it doesn't always work out of the box, right? You'll have something, yes, but it will rarely just compile and be green. And if you have something smaller, so think maybe you have a smaller GPU in your self-hosted cluster and you have Mistral Small running on it, yes, you will get tests, but you might very well have 30 compiling failure in it. And if you go through this feedback loop a few times, typically after a few runs, it's going to be okay, the compiling errors are gone, and the test will be green. And in case it's not green at the end, we also just remove the failing test so that we can still compile good metrics at the end. So that's for the approach. Now, there's still a few details, a few aspects I want to talk about. And the first one is, this is a bit simplified. So here it looks like basically the test writer is just getting the production code, and the error fixer is just getting the test code. That's not entirely true, because if you do that, it doesn't work that well, and you need to actually give the LLM the right input to make it work properly. So the LLM basically needs context, and why is that? Well, we need context too. So if I ask you, what is that? You might have different answers, right? Someone might tell me, well, I'm not sure, looks like a volcano. Another one that maybe has been to New Zealand might tell me, this is a mountain in New Zealand. And then if you're actually a fan of Lord of the Ring, you might tell me, this is Mount Doom. This is all correct, but what I actually want to hear depends on the context of this question that I didn't actually give you. And it's the same for an LLM. It needs context to be able to produce good answers. So what does it mean for code, or more accurately for generating unit tests with code? Well, your production code, you can give it just the one class, but typically your one class has dependencies on other ones, right? If it doesn't, you've probably done something wrong somewhere else. So let's assume it has dependencies. And information about these dependencies is very important, so you can, for example, define proper mocks that have the right signatures and so on. So how do we provide the information about the rest of the code? Well, one option would be brute force. Let's just give the whole repository to the LLM with each request. So you can do it, provided your repository is actually small enough, because every LLM has actually an input size limit. So if you try and give it too much, then it just basically cannot, refuses the request. And additionally, even if your repository is small enough that it fits in this input, then you're basically flooding the LLM with irrelevant information. So what does that mean? That means you're using more tokens, so you're actually paying more money as well. It will take longer to get answers. And typically, the quality will decrease because there's all this irrelevant information that the LLM has to sort through to actually get to the proper relevant things. So you can try it, but it doesn't work that well. The other extreme would be make sure that you give the LLM exactly what it needs. You can do that. One way to do that would be by setting up some graph rag system. So you take your repository, you put it into a graph, and then you put it in the database, and then every time you do a request, you retrieve exactly pieces of database, pieces of your repository, and this actually works, right? But it's quite a bit of setup, and it's honestly overkill for this unit test here. So we found there's actually a sweet spot, which is a repository map. So what is that? Basically, it takes the repository and it condenses it into just the information needed for unit tests. The concept comes, and the code as well actually, comes from a tool called Ada. And we use it here based also on the tree-sitter library. So what this map actually contains is just a map of the type and call signatures of all the methods for all classes. So you have no information whatsoever about the actual implementations of the methods in there, just the signatures that we need to then be able to generate correct mocks. And this you can generate fully deterministically, no LLM involved, at the start for the whole repository, and then you have it. And still, we don't actually always need to send this entire map. We can send just the parts that are relevant for the class that we actually want to test. And for that, we have some rough ranking algorithm that can find out which parts are actually related. And then we have some threshold based on the size of this map and how much token budget we have to send to LLM to say, well, at some threshold we stop and we just send what's over that. So that's the way we provide context to this LLM, which is both, I mean, I wouldn't say low-tech because it's not, but classic and still not overkill. And this again makes a big difference to the quality of the answers that you get from the LLM. So that's for the input to our tool, or rather to the components. There's still a few important aspects. One is security. So if you've been paying attention to the workflow, we generate the tests and then we run them. So that's automated, right? So that means we get code that comes from an LLM, we don't look at it, and we just run it. Don't know about you, I'm not too keen on doing that on my machine. So we need some level of isolation, and our solution to that at the moment is using Docker. It's not perfect, right? But the generated code always runs in a Docker container. We still have a version that runs without Docker for people that are less risk-averse than me and accept to run it on their machine. And of course, then the setup of the tool is actually a bit easier as well. Then, what languages can we currently generate tests for? Currently, we have Java, we have Kotlin, though for Kotlin, it's a bit more experimental because there's a lot more flexibility than for Java, and the LLMs tend to also hallucinate a bit more, so it works a bit less well. We have TypeScript, and we have C# that can all be generated by our tool for unit tests for these languages. Then, you might ask a good question, which is, yes, but I mean, why would I use your tool? There's so many other things, other tools that can do it. So there is all these coding assistants that you might use in your daily coding. So talking here, Copilot, RuCode, maybe Cloud Code, whatever you're using. Can they write unit tests for me? And the answer is yes, they can, absolutely. But you will have to invest a lot more time in it if you actually want massive amounts of unit tests. So where is that? So basically, they work because they follow a similar workflow to the one we have in our tool. They typically will also first write the test and run them, then correct them, and so on. But they actually have full freedom to do that. So that means there's a lot more places where they can actually take a wrong turn and do something you do not want them to do. What are the things you don't want them to do? Ignore your instructions. So sometimes they'll say, well, I've generated you 200 unit tests, there's 3 failing, who cares, it's good enough, right? And I'll just stop here. Sometimes you tell them, well, I want you to generate tests so I have a coverage of 80%, and they'll say, yes, 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 I've generated tests. Yes, I've reached the coverage of 80%, but they have not even computed it, right? They just made it up. The last thing you don't want it to, or one of the other things you don't want it to do is our tool, the goal is to test the code as it is. So we want to write the test and fix the tests. We don't want to change the production code to fix the tests. And you can tell it to these agentic tools that have a lot of freedom, but sometimes they just think, well, whatever, right? I'll just change the production code instead, it's gonna work. So they work, and if you're just, currently developing one feature and you want to change or add a few unit tests, and you're anyway using these tools, and you're anyway going to look at everything it does, then yes, these are great. If you, however, have some legacy code base and you want maybe hundreds, maybe thousands of unit tests for your code base, this is going to be very, very time intensive to use these, because basically you have to babysit them at every step, at every turn, check they're not doing what they're not supposed to do. And so we strongly believe that actually for large code bases where you want large amounts of tests, our tool is much better suited than these. And the larger your code base is, the more complexity there is, and the more the freedom of these tools also becomes a curse. And therefore, then we think that our tool for these cases work best. Now, I told you at the start, we can actually evaluate our tool. So we've done just that, and I'm going to show you some numbers. But the first question is, which numbers? Many teams use metrics like code coverage to decide how many tests they need. And yes, it's an existing metric. It's not necessarily the best metric, because this just says how many lines of your code actually run by the test. And so I have this example here of a test again. It's the same as the start. So I've told you it tests absolutely nothing, but it's actually going to produce some good coverage because it's running the code, the production code. So this shows that this code coverage metric is not good enough to actually evaluate our tool. What we use instead, which is for some reason a bit more confidential, is mutation score. What does that do? There's libraries for it, so you don't have to do it yourself. Sorry. And basically, it takes your production code, it makes some changes, so it might flip a condition somewhere, change a constant, removes an if, things like that, and then it looks, do your tests actually break? If yes, they're good tests, right? They're testing your logic. If not, they're not good tests, they're not actually testing your logic. So we concentrate on this mutation score to evaluate our tool. Sorry. So we have some numbers. Basically, we have an evaluation set. We have some classes from open source repositories, or Java, and with different complexities. So everything from Spring Boot examples to some threading benchmarking in there. And then we generated tests for them with our tools, and we generated tests with different commercial models. And what I'm showing here are the number of classes that achieved at least 80% mutation score, so mutation coverage, or between 0.1 and 80. And the missing part is basically these the classes for which we achieve absolutely nothing, so we have either no working test or no useful test. And you can see not all commercial models perform exactly the same. Currently, for our evaluation test at least, the best one was GPT-5. It's also the slowest one. The second one was Claude Sonnet, which, not surprisingly, is better than Claude Haiku. And then somewhere in the middle was Gemini. And here I must say it's not so much about the quality of the model in these numbers, it's more because the API was not stable, or is repeatedly not stable. And so we have some retries, but at some point we just give up, and then we don't get as many tests as the other ones. Then you might also not want to actually send your code to these commercial LLMs. Then what do? Well, there's open-weight LLMs, and the question is, how well do they perform? Well, it depends on the LLM, really. So here you have a comparison of the best commercial LLM we had just before, so GPT-5, with a few of the open-weight options. And, well, the summary is, if you look, for example, at the DeepSeek Chimera, which is the model, or a model that TNG developed in-house, or some colleagues, as a fusion of two other DeepSeek models, it performs fairly well. It's nearly comparable to GPT-5, and you could definitely use it also in practice. Quencoder performs quite well as well, just a little bit less, and also not very surprising. If you have a smaller model, it performs less well, right? Mr. Small, you still get some tests out of it, so you can definitely use it to get some coverage, but you won't get as much as for the other one. Of course, for this, you need much less GPU power, right? So it might be more affordable for your infrastructure to run this. All right, so that's what our tool can do. The message here is use it for your big code bases, and of course, depending on your LLM, you get different results, but most of them will give you some good tests. So now let's look at end-to-end tests.
Right, so Marie gave you a nice reason why it's tool to do unit tests with AI, I'm now in the position to tell you why also the other end of the testing pyramid here is relevant and worth it to look at when it comes to trying out things with an AI agent. Well, what do end-to-end tests want to do? You want to emulate actual user behavior, and they are also by their nature black box style tests. So you don't want to actually rely on logic in your code for writing your test. It's actually rather detrimental to do that because you might be testing implementation detail and someone who uses your application does not see your code normally unless they open the browser developer tools and have some moments there figuring out why your page is not working, but normal people don't do that so much. So writing end-to-end tests requires a different mindset, you could say, compared to development work and writing unit tests. So why not say like, okay, I'm the developer, I wrote the code, I'm just gonna push the basics of writing that end-to-end test to an LLM that doesn't know about my code as I do. It's also at the same time a thing that for end-to-end testing, obviously non-technical people tend to be more involved because there you want to test like a full business process, for example, and then you will have someone who is responsible for that process tell you, I want this thing to work exactly like this. And they don't usually talk about your unit tests in your code. So you can use an LLM there to provide a foundation of tests that you can then extend, and you don't have to figure out the basics, so to speak, for this. So you can start with a natural language description. So an example here is, we go to a page, a web page, in this case the dashboard Digitale Verwaltung, where the German government provides you numbers how many of our administrative services are already digitally available. Then, typically for such a test, you have a clear instruction here. Okay, reject the cookies because everybody has a cookie dialog. And then go to the Landkreis section, look for München, and find out how many services are available overall and how they are split up on that page. And then you expect a result. You want to say like, okay, I get the numbers for München, which is 1,697 available services overall, and a drill down into the other ones. And from that description, you can already see you can do that yourself. You don't need to write code or something for this. You can just do this with what I did in the beginning. Wait a second, I need to do this differently. Screen share topics. Right. I mean, this is a video of me going to that page and doing the clicks. And it's probably not a very effective use of my time, but here we are. You can do a test yourself. And we got the expected results here. Actually, the numbers changed, apparently. So, but basically, these can be also the subtle little things when writing these kind of tests, like suddenly the numbers you asserted for change because someone made an update. But what do you use these for? You make sure critical flows in your application work. I mean, you, as someone who runs this page, you want to make sure that anyone who uses this page can look up those numbers. They can use the map and go to the numbers for their district. You require that everything is working together, your entire system, and you're not mocking anything. There's maybe some real exceptional cases where you would do that. And often, these kind of tests are even the domain of dedicated QA people. Right, so you can operate a web front end here. You want to automate this. If you want to automate this, first, modern front ends tend to be web-based, so we need to control a browser. If you don't have a web front end, there's different things you can try, but we're going to focus on controlling a browser. For controlling a browser, there's a number of libraries. The arguably most modern one that people tend to recommend nowadays is Playwright by Microsoft, which provides an interface to automate a browser. And yeah, test web pages, basically. What then comes on top is a library, an open source library we used and actually heavily modified by now, which is called Browser Use, which wraps this Playwright library for an LLM agent. Basically, it adds code around it that you can then run an LLM that is aware of the browser. So you do annotated screenshots, you pass parts of the domain object model, so the HTML of the page, and you tell the LLM, by the way, you can click on stuff here. And yeah, the vanilla version of browser use is meant as something where you can do a like one-shot flow, so you can tell it, yeah, do this user flow, and it doesn't record anything or so, and if you want to repeat it, you need to run it again with the LLM. What we did was create a fork that records the interactions using Playwright methods suited for testing. So following best practices there more. And what this requires, of course, I talked about screenshots here, right, is you need a vision language model, so a LLM that is capable of also parsing images. And with that, I should simply show you how a run of the tool looks like, if the presentation plays nice. So yeah, basically the instructions are what I showed you on the page before, and we start up the tool as a CLI, and it opens a browser, and you start seeing these little colored boxes. And this is basically telling the LLM, then takes a screenshot and tells the LLM like, hey, this is what you can interact with. And then it just picks, based on the instructions, where to go. And we're done. We found the numbers we want. And now there's a test. I'm going to show you parts of that code also in a few slides, so no need to follow everything now. But yeah, you can run this test now, no longer requiring an LLM or anything. You can see we reached this point. There's an artificial pause, so we can show it here in the video. Basically, right at the end of the test, you can see the numbers again. And now, yeah, we ran it. We have one passing test. And that's that. Right, so what did you see here now? Well, I already mentioned the colored boxes, so we're going to talk about the starting point of this, the dreaded cookie banner, because, yeah, everyone likes cookie banners, right? So what you can see here is, on the one hand, yeah, the way things are annotated, like the buttons here having numbers. This one has 49. It's unfortunately the color with the worst contrast here. But yeah, you can see the LLM, which went through this and like, yeah, okay, I want to reject the cookies, and I have this list of things that I can interact with, and one of them says ablehnen. Yeah, this is probably the button we want to click, so we click it based on accessibility properties, so the role for the an element with the role button, and it has a name, ablehnen. And yeah, we click it. And that results also in a recorded trace of these interactions that we have, where you can see, in particular, this line. This is basically the line of Playwright code you would want, and this is the Python example, to click on a button that says ablehnen. And yeah, well, what can you do with that? You have a log and you have this trace with actually already nice commands that you want to run. You need to just turn it into a functioning test. The solution to that is just take the tool and put it into another LLM. Why another LLM? Well, we no longer need vision now for this task. And the number of vision-capable LLMs, especially that are open weight, that you can run yourself, is rather limited. And so now we can pick a better one. Actually, the ones that are used for this code here is the Qwen coder model that Marie showed on the earlier slide that was also pretty good at writing unit tests. And side note, yeah, you can translate this test into TypeScript, C# or Java, like the other languages that Playwright supports, quite easily. That's also just telling an LLM to do it. They are pretty good at these kind of things. And yeah, the test snippet that came out of our cookie banner interaction, you can see down here. You can see it got a bit creative. There's now a check if the button is even visible before it attempts clicking, which makes the whole thing a bit more resilient. So yeah, the flow overall ends up like we start with a test scenario, we feed it in this browser agent, that clicks to it, that produces the trace and logs that we can use to feed the test writer, which spits out test code. And then we can try running it. Sometimes, of course, the tests will fail. One source of this is that the test writer here got a bit too creative and changed too much from that. Then it just helps giving both of those things to an LLM step again, telling it like, fix this. And that works quite reliable. We don't have a full feedback cycle here yet, so this will still occasionally fail. But getting basically from here back to here is still in the works and is a bit more complicated because you need to get back into that browser environment again. And now to show you a somewhat condensed version of the test we produced. So it has different steps. There's the cookie part. Then you have this section which does interactions with different elements. For example, here we have this combo box, so this input field where we search for München kreisfreie Stadt. And that works, runs through. And finally, we have expectations or assertions. So we want to make sure that these pieces of text are visible in our test scenario, in the scenario we are testing. And yeah, this is actually a perfectly fine test. I think you'll always find someone who has an opinion that something there is bad, but overall this is something I wouldn't tear apart in a pull request review. Right, so we can produce nice tests. It turns out you can use this kind of tooling for some other related stuff. One is generating basic documentation based on the logs and trace. I mean, that's quite obvious. I mean, you have a bunch of information you collected while navigating the page. You can also create something called a page object model for Playwright, which is a best practice they recommend doing, which is an abstraction layer you put between your test scenario and the really interaction steps. Think of, for example, for every test you need to log into your page first. Then you don't want to repeat in every test like, okay, go on the username field, go on the password field. But you want to have some method somewhere that says login, and that gets called at the start of the test. And you can actually create and maintain these also with an agent-based approach like this. And finally, more of a side effect we noticed, which was quite interesting. Yeah, this thing is pretty good at finding accessibility issues on your page. Why is that? Well, vision LLMs are not as good as a sighted human at recognizing things on a page, at least yet, which means they are put in a somewhat similar situation like someone with a vision deficiency. And that deficiency could also be coming, by the way, from the fact that you're in the back of this room. So an example for these kind of things you have here, 2 versions of the same button. The top one has an arrow in there, by the way. In a larger room, that would be hard to tell, and with a different projector, maybe. Yeah, while on the bottom, you have something that's pretty clear in what it does. And the code behind those is also examples of how to not do it and how to do it. Like there's semantics here that making this an HTML button element and not just a generic div. And yeah, turns out if your page does the upper option, the LLM agent will also stumble around blindly on your page. Same as before. Yeah, there's alternatives. Of course, the LLM tool landscape is big. There's a lot of stuff that is published every month, basically. We looked at 3 kind of alternatives to our tooling. Found with all 3 of them, they can struggle more with complex flows compared to what we built. So that's a nice thing to see when you wrote something yourself. The most well-known, probably, if you're in that space, is Playwright themselves published an MCP server. So MCP servers being the de facto standard now for giving tools to an LLM. This thing, yeah, struggles. It is potentially better if it actually also knows the code. For example, it's integrated, the Playwright MCP server is integrated in the Cursor IDE. The downside here is this requires an LLM that's both good at vision and coding tasks at the same time, something like Claude Sonnet 4.5 is. But if you want to use an open weight model, as said, this limits your choices significantly. Similar things hold for the RuCode IDE plugin that can also interact with the browser. That one produced pretty working tests, and but the ways it located buttons were actually not good. And another interesting candidate is another MCP server for the Chrome developer tools. That one wasn't particularly good at writing tests, but it can do many interesting things, as in using the browser developer tools. So we're looking into this to use it as a debugging tool for our setup. Right, where does this leave us for both of our kind of parts of the talk? Well, we started this whole thing end of 2024. We got some nice results, so we continued, obviously. But I already mentioned it, every month there's 3 new tools in this space, and things happened a lot. And yeah, you're now looking at things like Claude Code or these MCP servers and go like, there's not that much maybe, but hey, we're still somewhat better there. But yeah, you can be caught by surprise with these things, how quickly these happen. So who knows what will be in half a year. I still like the stuff we built. There's also some limitations. Your code or your front end needs to be testable. An LLM is not going to save you from absolutely terrible code that you would hate to write tests for yourself. And the tests, as Marie said, are generated for the current behavior of the productive code. So if there's a bug in that code, it's not going to fix it automatically. There's ways of telling things, though. So we got feedback from colleagues who tried this out, who went like, yeah, and then for this one function, we got like non-working tests or really funny-looking tests. So we checked the code again and found 2 bugs and suddenly understood why the tests were not built correctly. So yeah, do code review. Great recommendation. There's also such a thing as having too many tests that you can write. I mean, that's why we used, for example, this 80% criterion for the evaluation and not 100%. Right, and where do we think about going from here? We want to keep improving our UX because also developers like shiny tools. And we want to explore further use cases for the end-to-end setup in particular, and test-driven development is also something interesting. Thank you for listening. If you want to see the tools live, the exhibition's down there, and I'm going to be there, well, after lunch. Thank you.
So thank you for this insightful talk. And are there any questions?
Thank you for the talk. It was really nice. I actually have a bunch of questions, but I'll try to condense into 2 maybe. The first one would be to the end-to-end test generation part. The question is if we can already utilize these page object models that already exist. For example, if we have some existing code that we've already developed some end-to-end tests for and we want to integrate this tool, is that a possibility?
That is a highly prioritized ticket in our backlog.
One more. Sorry. Yeah, sorry. This is a good tool. I have questions about it. So my other questions for both of these tools. Have you tried testing it for example, within like a CI/CD pipeline, to have, I would say basically to eliminate the fact that you have to write tests.
Yeah, I see your point. Basically, I mean, for the unit test writing, we definitely considered that use case. It just moved a bit out of scope because we wanted to build a CLI around it first. For the end-to-end testing part, I think just coming up with the test scenarios there can be a bit tricky. There it's better to just have someone write it in natural language and then feed it.
I have a question about the unit test generation. You said that for the input you give it a repository map, so that included the signatures, you said?
Yes.
Have you experimented with also giving it the documentation comments in case there are any? And does that help? Because LLMs are pretty good with natural language, right?
So I don't think we actually experimented with that. You can correct me if I'm wrong.
I mean, I think we experimented with generating documentation comments itself, where a terribly written function then got deleted by the LLM instead of documenting it. But yeah, it's a bit of a two-edged thing, because then you have this thing of the documentation getting out of sync with the implementation. So yeah.
And also the documentation might actually be giving information about the implementation, which is actually what we do not want for dependencies, right? You don't want to know how they work, you just want to know how they look. So.
Yeah, thank you very much for the talk. I was wondering, how difficult would it be to use that tool with a language that is not yet supported? Is it just a matter of fact of telling it, use this tool for compiling and this for running the tests, or is it more involved?
It's more involved, because basically we have to implement these mechanisms ourselves. Like, we are not telling an LLM, you have this stuff. And what we found is the more freedom the language allows you in terms of specifications, compare Java versus TypeScript, JavaScript. Like, the harder this gets, because yeah, for TypeScript we now had to implement npm, pnpm, and then there's vtest, there's jest, and there's different other libraries, and you need to parse everything. So there's quite a bit of engineering there, which is the reason why we stayed away from Python up to now also.
But the effort here would be really on the setup side. Yeah. There is no restriction on the LLM as such. The LLMs will happily give you any language you want, essentially.
Yeah, thank you for the very, very insightful talk. I was wondering if you have any experience of going one step further to transform basically a legacy project into a new tech stack. So you can try to guide that via tests that set the guardrails for the new framework, basically.
So the actual migration, we actually have a team, another team doing that. I'm not sure if they're giving a talk today, but sure. They probably have an exhibition
it's right
down
next
there,
to our exhibition booth.
So you can definitely talk to them. Of course, if you're talking about generating tests to guide the migration, the end-to-end test part of thing is much more suited, right? Because unit tests, you're just going to throw them away anyway with the old code. So, yeah.
All right. So thank you, and also from TNG, a big thank you. So there are two presents here. One is an AI-generated children's book, some chocolate and a car.
Thank you.
Free food.
So let's thank our speakers once again. And if you have more questions, which I'm sure many of you do, there's this booth that's already advertised that you can go to and ask him all the questions ever. So.
And if I'm not there, someone else from my team will be there. So.
And so with this, also